Okay, time to start looking at what are rational numbers, what are irrational numbers, and let's get a flavor for how they work. So look at the definition once again. An irrational number is a number that cannot be expressed as a fraction, okay? And cannot be expressed as a terminating or repeating decimal. So in other words, you can't have, let's say, like 6.3 repeater, not irrational, or 2.571. Well, that ends. That's called terminating. That's called repeating. Those are both not irrational numbers. Those are rational numbers. So how do we go about doing this then? Okay, let's take a look at this. And the best way to do it is throw every single number in the calculator and see if it follows this definition here. Okay, so here we go. Let's bring up the calculator. Now, with this calculator here, I'm going to go to the first one. This one's pretty obvious. This one's already expressed as a fraction. We know it's going to be rational. But I want to show you something which is really neat. Let's put a -3 divided by 5. Let's get this. Check out the number. The number is -0.6. This is -0.6. This decimal stops. It terminates. Automatically, that's rational. That's a Q. Look at this guy now. This will be interesting. Let's bring up our calculator once again. With the calculator here, clear second square root of 14. Watch what happens. Boom. There's no pattern to this. It goes on and 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 on, and there's absolutely no pattern to this. So guess what? This is your first example of an irrational. There's your Q bar. You see how it works? Okay, this one's pretty obvious. It repeats. That's got to be a Q. Look at this one. This one ends. That's got to be a Q. But how about something like this? That looks like it's set up for an irrational, isn't it? But think about this. What is the square root of 49? The square root of 49 is 7. What is the square root of 16? The square root of 16 is 4. Guess what? That's a fraction. That's a Q. Okay? But how about something like this? There's 2 square roots. Oh my goodness, this sounds really, really difficult. That's not either. Look, this is a square root of 16. Square root of 16 is 4, but we're going to square root it again, which is this guy right here. Square root of 4 is 2, and guess what? That is just a plain old number. That, in fact, is a rational number. That's the Q. Now, I know what you're saying. Well, you can't put that as a fraction. Yeah? Watch this. Any number can be made into a fraction. Just put it over 1. How about the next one then? How about this one here? Cubed root of 8. Well, if you actually do the cubed root of 8, you will notice that that actually equals to 2. How about the cubed root of 27? That actually equals to 3. So guess what? That's a Q. But how about this guy way out here? Don't forget our lovely little pi. We have to always include that. That, in fact, is a Q bar because, after all, it shows up right here. Okay? So let's keep on going. Let's look at every one of these and tell me, is it rational? Is it irrational? Well, this one being a fraction, you know right away. That's got to be rational. There's a 0. 0 can be made into a fraction over 1. Guess what? Rational. How about root 3? Well, I don't know. Does root 3 actually have a nice number here? Well, let's figure it out. Square root of 3. Well, if you look at that, this looks like at the end here, it looks like it's starting to repeat itself. But if we could actually get in this and look a little further, we'll find out that it has no repetition. That last number is actually rounded. So this, in fact, is Q bar. So what does that mean? Well, when you put it on the calculator and it goes as far as this one, yeah, chances are it's going to be a Q bar. How about this one here? Well, that stops. That stops, tells you right away that that's a rational, that's a Q. Here's a nice number. Well, we know that one to be an integer, so that's got to be a Q as well. And then let's look at this one. Square root of 64 over 5. Let's put that in our calculator. Let's see what we get. Oops. Square root. Let me clear that out. Square root of 64 over 5. So second square root, and any kind of fraction, always put it in a bracket. 64 divided by 5, bracket. Let's see what it looks like. Look at that one. No pattern, doesn't end. Got to be a Q bar. Okay? And finally, 121 over 64. Let's look at that one. Even if we put that into a calculator, second square root, 121 divided by 64. Oh, I didn't put it into a bracket, so let's put the bracket in there first. 121 over 64. Now, what do you think? Is it going to be a Q or a Q bar? Let's check it out. Boom. Oh, it terminates. It stops. Look at that. It stops at 0.375. That, in fact, is a rational number. So there's some really beautiful examples for you to figure out what is rational, what is irrational.